Nayak, and I've completed the task 2 of the Data Science and Business Analytics internship at the Sparks Foundation, where we have to predict the target column or the species of on the iris dataset using unsupervised learning. So firstly, I've imported all the required libraries like the pandas, numpy and matplotlib.pyplot library, and here I have stored the iris.csv file as a data frame in df variable using pd.readcsv function. And we can see here the first five rows of the dataset. Here we can see that there are four features and one target column. So using ilog function, I have stored the features column in the features variable and the target column in the species variable. And here we can see the 2D features array and the 1D target column here, this one. So now I have plotted the elbow. I have plotted a graph between the inertia and the number of clusters to find out the appropriate number of clusters. Now, inertia, intuitively speaking, measures the distance between the data points in a particular cluster, and a good model has less inertia and less number of clusters, but there is a trade-off because the initial inertia and number of clusters are actually inversely related. So we plot this graph, and we take the point at which a sharp turning or the elbow of the graph is located. At that point we take the number of clusters. So from this graph, we can see that the number of clusters is 3. So now I have imported the k-means model from sklearn.cluster library, and now I have created an instance of the k-means model where I've given the number of clusters as 3 and the init parameter as k-means plus plus. Now it simply means that it will be selecting the clusters in a smart way to speed up the convergence, and I've given the maximum number of iterations as 400. It means that maximum of 400 iterations will be taken place in a single run, and n init as 10. It means that the number of times the k-means algorithm will be run with different centroid seeds is 10, and the random state is 0, so that while we run it a number of times, the value of these labels remain fixed. So then I have fitted the model using the fit function, and I have predicted the values and stored it in labels variable. So now I have performed, so here we can see see this that I have performed a cross tabulation between the labels variable and the species variable. Sorry, here I have performed a cross tabulation between the labels variable and the species variable to find out which cluster belongs to which species. So as we can see that label 0 belongs to iris versicolor species, label 1 belongs to iris setosa species, and label 2 belongs to iris virginica species. So since here it is a simple and small data set, so we didn't have to perform any standardization or normalization, and simply from cross tabulation we can know that which cluster represents which class. So now I have plotted a scatter plot uh, of all the data points showing which data point belong to which cluster along with their centroids. So we can see that this blue color, cyan color belongs to this iris versicolor species, that yellow color belongs to iris virginica species, and this purple color belongs to iris setosa species. And these are the respective centroids. Thank you.